I'm glad to be here. I came from China, and yes, this week is in Geneva for the AI capacity network discussion with, under the Union Nation, and also participate the ITU AI for Good Summit. Yeah, so I'm happy that it just takes 3 hours train last night from Geneva to here, and this evening I will fly back to Beijing. So that's good to have this chance to, and also open this window, allow me to here to introduce our work, and also I think this is really important to open the door, open the window for more communication and collaboration. And if you want to connect with me, my name is on my LinkedIn, Yong Hua Lin, but between Yong and Hua there's a space, okay. Okay, so today I will a little bit first, very short to introduce what is BAAI, but mainly to share you our current progress and journey in China. And I wish we can have more collaboration between China and Europe and global, okay. And the BAAI, actually we are the neutral NGO, purely research institute for large model. We established in 2018. Nonprofit, we are not belonging to any government organization. We have the collaboration broadly in enterprise, academic, and also global. And usually we will divide our research in 2 layers. One is the very frontier research. Actually, we have the largest LLM model be trained and released in 2021. That is called Wu Dao at that time. But after that, since a lot of enterprise joined into this market, so from 2023, we continue our innovation from multimodal model, world model. So here you can see the physical world model. We have the EMU 3.5. This model is the native, the multimodal world model, the first one in the world. And so earlier this year, Nature published our work. That is the second article and second large model on Nature. The first one is DeepSeek, the second one is ours. And we also have the embodied AI models for robot, the large model for robot. We have the series model called the robot brain, and quite recently is the ORCK, Orca. You can see it on Hugging Face is on the trending, the #1 in trending quite recently. We also have the innovation research on the AI for science. We have the open complex model, and it already exists, the performance of AlphaFold 3 has a close performance compared to AlphaFold 4, and we target to open sources in the second half this year, okay. And we also believe that for all the innovation for around the large model, very, very important is all the technology under the water. That means the data research, the evaluation research, and also the system research. But all of our technology, we open source that. Since we are the nonprofit research institute, so we just open source all our innovation. So till now, we already open source more than 100 data sets on Hugging Face, open source more than 115 the open models on Hugging Face. I don't know if you know there's one model called the BGE that has been downloaded for close to 600 million in the past years. We also have developed a so-called open compute. I will talk about it later. It's to solve the computation problem. And we also have the very broad collaboration in global. And on one hand, we very active in academic research. So here on the left-hand side, you will see just the last year AI index published by Stanford University. We named as a top the scientific paper organization. But more interesting is on the right-hand side, actually from BAAI, a lot of current very important AI model, the leading company, their founder is actually from BAAI, including the GLM founder, Professor Tang Jie, including the Kim's founder, Yang Zhilin. He's actually the intern in BAAI when we developed the Wu Dao large model. So we believe that, yes, just now I also hear a lot of our very important distinguished speakers say, yes, Europe, you should have your own model and your own large model training activity. Yes, because at least one very important is we need to build our own talent through the innovation here, okay. That's our practice in China. Okay, and the BAAI is also be very truly open. Yeah, since I also noticed you talk about the open model is just open weight, but not only open weight enough. We also need to open source our training code, inference code, benchmark code, and also the training data set and test data set. So actually in Linux Foundation in the past 2 or 3 years, they developed called the Model Openness Framework. And actually in 2024, we are the first model past the class 1 criteria, the most open is the model. We open source all the things. Yeah. Okay, then I want to start from the data set. Yes, I always will reference these 3 the most important data set in my research career. I do think that without them, we cannot have today's AI, we cannot have today's large model. I know that today I noticed that you also invite some researcher from Common Core. Yes, that's the great data set, okay. But for China, we have our own language, Chinese. So only this global, the very important data set cannot solve our language issue, because we found that, for example, use Common Core as example, it has only less than 5% of the data belong to the Chinese, and a lot of high quality data set, Chinese data set is not in Common Core. So that's why from early of 2023, around 2 or 3 years ago, when ChatGPT opened its service, we found that its quality to answer the question in Chinese is so poor, the quality. We know that because at that time in the world, there's no high quality, large data set in Chinese. So that's why from early of 2023, BAAI drive the effort in China. We team together more than 30 different organizations, including the Peking University, Tsinghua University, and also the Baidu, Tencent, Ali, those big giants, because they have a lot of internet data, and also a lot of publishers in China. We group together, we ask them to donate the public available, those data sets they think is okay for open source. We group them together. So we spent more than 2 years to build up this Chinese corpus for internet. It is CCI. And yes, the last version actually is released last year in Paris, because we attend Open Source Summit last year in Paris. Yes, every year I will participate the Open Source Summit in Paris. CCI 4.0, that is already become the largest data set for Chinese, and today a lot of, almost all the large model, the teams, when they train the model with the Chinese capability, they will use this data set. So that's very, very important to allow the world to have the high quality data set for our language and culture. I believe that's the same for any country in Europe, okay. And we also think that what's the next, right? What's the next data set will be important. And we all know that robot is so important, and to train the VLA model or the word action model for robot, we do need a high quality data set for robot as well. And to get that kinds of real data, the data in the real world with the real hardware is more difficult than the internet data, okay. So that's why in the past 1 year, we spent a lot of the resource investment to collect the data from 15 different hardware, robot hardware, covered a lot of different scenarios in real world. And finally, we come out of this RobotCon, the very, very large, huge data set, and we open source on the Hugging Face. And just half year, 6 months, open source 6 months, we got 7 million downloads. So I hope this can become very helpful for any of our innovation for the embodied AI models. And we also look forward to the collaboration for the open source collaboration here. For Chinese, it might not be a little bit difficult because the language gap, but I do think this is one of our collaboration opportunity. If any of you have the interest to collaborate on the next step, the open source data for robots, yeah, we are happy to do that together. Okay, then the evaluation. Evaluation is also very important. Our institute, since we focus on the large model research, so at the very beginning, we realized that we do need the research in the large model evaluation. Without that, we cannot build a measurement, we cannot build a ruler to measure the large model. In the past years, yes, we already changed our research direction step by step according to the large model's evolution. We start from the foundation model to mainly challenge if the model can answer the knowledge questions from human. And then we also have a lot of research regarding the reasoning model. And since last year, agentic system became very hot, so we also put a lot of our effort to do the agentic system evaluation. And this year, we also established a lot of evaluation effort around the embodied AI. This is what we built. We call the Flat Eval. This is an open platform for the large model evaluation. It covers the different modality of the model's evaluation, and we allow the people, developer, they either submit the model itself or submit the API. Then our platform can do the evaluation, and the developer can select which benchmark he wants to do the evaluation, and they can monitor the evaluation progress, results in progress, and also the final result. And we also collaborate with Hugging Face and published a lot of leaderboard. So in the past 3 years, we already evaluated more than 1,000 models. And here, since it's in Europe, we also are very glad that we actually, from last year, we collaborate with Eclipse Foundation. We do see that, yes, Europe, you have the more strict and safety consideration and trust consideration for the model technology. So we donate our technology under Eclipse Foundation, open source donate, but Eclipse Foundation use technology to build a pan-eval, fully established for Europe and here for Europe. So it satisfied all the data privacy issue, and more important is for Europe, we do see a lot of very important industry. So under the leadership of Eclipse, and they will establish the industry group to establish the 1, 2, 3, 4 different model evaluation tasks, which will be important for Europe industry. So we are also happy that if we can also collaborate in this area. Okay. Okay, then I want to go to the very important point is about the compute. Yes, in China, we already moved from the model race to the deployment race, because we all know that from ChatGPT to the open core, the very important is not just rely on the single model's performance, but for the agentic, the AI system, the bottleneck is the computation infrastructure. Can we have an efficient computation? So usually we will look at the very system level token efficiency, okay? And usually we will divide it into 2 layers. Upper layer is the large model, agentic AI framework, and also the skill you will use. It will, you will determine if we can use less token to finish the job. If we can use less token to finish the job. So that's a kind of token efficiency. And above that, below that, it is all the system software and also the chipset. It is to determine if we can finish the tokens, have higher throughput for the token, or to lower the unit cost for the token. So these are the 2 very important 2 angles, totally design the whole overall system level token efficiency. So that means that token cost is the model capability plus token efficiency plus the underlying the system efficiency and also the hardware efficiency. Okay, let's look at the large model, the model efficiency first. We, in last year, evaluated the token efficiency among the different reasoning models. We had the full paper article on archive you can download for more result, but here I just point out two things. One is, actually we developed the more than 600 new reasoning cases specific for this overall evaluation. And first is we want to see if the reasoning model, when they finish these 900 different reasoning cases, how is their accuracy, the correctness, versus the token they used, okay? So that means, yes, on the left-hand top side is the best. So it will help us to see if we want to get a high-quality result, high correct ratio result, which model can save more money for me. I don't need to use so many tokens to finish the task. So that's one angle. On the right-hand side is, we found that you might also notice when you use the reasoning model, if you think long way, then they give you the result. So we compare the thinking process with the result. A lot of time we found that the thinking process, the thinking is not consistent with the result. Sometimes the thinking might say, okay, this is not correct, but the result you got is correct. So, or sometimes the thinking process say, okay, I'm not sure, I don't know if I know, uncertain, but the final output for you is, okay, I certainly think this is this way, this way, this way. If that, we need to consider that kind of thinking, is it will waste our token? So that's why we also need to measure how much token we might waste in the unnecessary tokens during the thinking. So these are just two examples. We measure much more different angles, including the redundancy, others. So just look at the article. I don't want to spend time on that. So because, because we publish these kinds of results, also get a lot of attention from different teams. So we do see the, better result now. This is just in this year, in the first 6 months, we collectively see that in global, including China and global, have so many different open source model released. So yes, today, especially a lot of China team, the model company, they keep open source top models, okay? And some summarize I want to mention here is, yes, today for China, the top model team very actively releasing the better model. And they usually will move from the foundation model to stronger post-training model. You can see, for example, here, Minimax, they open source the foundation model M2.5. And later this year, they open source the M2.7. So this is actually the stronger post model based on their foundation model. Similar pattern, you can see that for ZAI, the GLM5 and versus GLM 5.2. So these are very common pattern. And we also see that, yes, this year, most of the model, when they open source, the flagship model is hundreds of billions parameters. It's a huge model. Of course, it's under the MOE architecture. So it gives us more challenging in the architecture inference optimization. And also another observation is for the precision format, FP, floating point 8 and floating point 4 start to appear in the open release model. And this also challenging the hardware. Most of our hardware today already largely deployed hasn't supported FP8 and FP4 yet, okay? Okay, I want to skip this one. So just now you will see that that is the race for the model and challenge for the model. And then let's look at the hardware itself, different AI hardware. Because, because the token, we need the much efficient hardware, which can do the large model inference. It is not only for today's LLM, but also really need to prepare for tomorrow's world model. It's more challenging to do the inference in real time. And also, if we really want to use this kinds of world action model in the robot, then we also need to 10 times make the hardware more efficient than today, okay? So that's why we can see in global, including the global and China, the whole industry, it's still under rapidly evolving for the hardware. So it always it will be considered a single chip computation scaling to scale the single chip capability. And then people will think about, okay, how about we group a lot of chipsets together to make the super node more efficient, so that's to solve the interconnection efficiency. And then we will see that data access becomes more important. The data access between the compute and memory, that is very, very important. So we need to also break the physical barrier to do the physical reconstruction, to use a chiplet, 3D, and also near memory computing, these kind of things, different technology, just to make the compute more close to the memory so that we can have either the higher bandwidth or more low latency for the memory access. And also, we also have the decouple the different computation format into different chipset. So some of the company, they also think about to specific have the chipset for decode only or for the prefill only, okay. All these kinds of innovation also need the system software innovation to match this hardware innovation. If there's no software innovation can match this hardware innovation, then all the hardware innovation cannot present their architecture efficiency, okay. But today, the ecosystem is very fragmented. Most of the chipset from different companies, they have their own vertical software stack. Each chipset might have their different architecture, but each company will have their own compiler, their own language, their own the communication library. So this is very, very fragmented. So that's why when we have the open source model, we want to migrate it onto another chipset. That's a headache. So that's why we propose the open compute for AI. The idea is simple. We want to have this kind of open source, fully open source software stack, which allow our latest algorithm and model can freely, easily run on different vendors' hardware for different architecture and even for different generation, okay? Since today, we also see that for the chipset company, when they have a newer and newer chipset, the architecture will change a lot as well. So if we can build that, that means we can have more choice, can lower the cost, or reduce the barrier. Let me take one example. That is the DeepSeek version 4. We collaborate with DeepSeek company, and we got their model ahead of time. We found that there's a lot of innovation, extremely the optimization for the hardware to get the high throughput for tokens. And two things we found that. One is the original code and model is the mix for the FP4 and FP8. And the other is, if we don't change any of their code, it only can run on the device which have the local memory larger than 80 gigabytes. So with these two conditions, that means at that time in China, almost more than 95% of the deployed hardware cannot run this model. So that means that we need to figure out a way to allow this frontier open model can run on more chips, okay? Otherwise, they open source that. But we cannot, even we can download that, but we cannot find the hardware to run that. So that's why in the past 3 years, BAAI together with a lot of academic research in China, chipset company in China, and global company, we collaborate together, build this software stack for open compute. It's called the Flat OS. It's not operating system. It's the open software for the AI. The target is to run the AI everywhere. We today can already support the chip from 18 vendors and 32 AI chips. Here include NVIDIA, include ARM, include a lot of other chipsets. And we recently also, NXP from Europe, they are also use their chipset to integrate into this stack as well. So in this, yes, this is a very difficult technical challenge because the underlying chipset quite different architecture. How can we have the unified or open source shared system software can allow run the things efficient and similar on these different things? So that's why we built up the compiler. We extend the Triton language to a more efficient language called PLE. We also build the unified communication library. We also build the largest operator libraries to support a lot of chipsets. Very important is here, is called the unified device plugin for training and inference framework. Because today, for training, we have the Metron, Transformer Engine, PyTorch. We also will have the VRM, SGLang for inference, and also more for reinforcement learning. For this very popular framework, we need to develop the plugin to allow the different, this multi-chipset capability can use that. Yeah. Okay, and we also need to build the pipeline to allow once the model open source, we can very quickly to analyze the code, the model's feature, and to migrate it onto our open flat OS stack. Then to run it and test it on different hardware. Once it passes our test, then we again release back to the community. So we call it the flat release. Today on Hugging Face, you can just search the flat release. You can see the model's name and also the hardware's name. So we just imagine that. You can think about for the MySQL, for example. Today, you use the MySQL for x86, you use the MySQL for ARM, you use the MySQL for PowerPC. You will not need to compile it by yourself. You just download its version, okay? So it's same idea. We don't want our developer to do the migration by themselves. They just download the model for this architecture name, then run it, okay? So that's how we partnered with large model teams in China, and they usually will 1 or 2 days ahead give us the model. We do just 1 day to finish all the migration onto up to 10 different AI chipsets. Then once this model formally open sourced by the model team, we can help them to open source a lot of different architecture available, the version on the Hugging Face. So it will help the model can have more developer can use them onto different hardware environment. Okay. And oh, sorry, because of time, I might skip this one. And this is very important. This is the Open Computer Initiative for AI talent education. The idea actually is around 1 year from here. We have discussion in Paris, we have discussion in Geneva. The idea is actually today in global, including China or other places in the world. There's a lot of out-of-date hardware which deployed 2 or 3 years ago, underutilized for the AI. Okay, a little bit older version of the AI chipset. Okay, so the idea is, can we group them together to install our stack so that we can allow the latest model can run on this old version of the hardware? Since this hardware underutilized, it's cheap and even free for use. So we can group them and provide it to the developing country for them to do the AI education. Because today, for example, Africa, they want to build their talent, grow their talent, but they don't have the resource to do the homework, to do the practice for AI. So that's why we actually work with UNESCO, work with the African Union, and early of this year, we invite the teacher to China to have 2 weeks to education. Then when they back to their home country, they launch the AI course, and they use our open computer platform remotely for free. And actually, behind that is from the different vendors' hardware, which already out of date. Okay.
And Yong, we need to wrap up. So yeah, please.
This is the last one.
Perfect.
Okay. So yes, we really want to look for the collaboration because we do feel that open compute, open education, open data, and we can open more opportunity. And we also building the open source AI Alliance and global initiative for AI. So we also highly welcome teams from Europe to join together. Thank you.
Thank you very much.